Today, we're going to take a quick look at orbits. We can describe an orbit as the curved path of one celestial object, or spacecraft, around another celestial object. So this could be the Earth orbiting the Sun, or the Moon orbiting the Earth. The question we're going to try and answer during this video is to explain why objects actually orbit like this, rather than just flying off in a straight line, or being pulled in towards the object that they're spinning around. Well, we know from Newton's first law that an object travelling at a certain velocity will continue to travel at that velocity unless it's acted upon by a resultant force. So if the Moon is travelling in this direction at 1023 meters per second, which we call its instantaneous velocity, then it should continue to travel in this direction and at this speed forever. However, because the Earth is so massive and relatively close to the Moon, it exerts a strong gravitational pull, which is felt as an attractive force towards the Earth. Because the Moon is quite big and travelling very fast, it has a lot of momentum in this forward direction. And so the gravitational force isn't strong enough to completely pull it in towards the Earth. It can only change its direction very slightly. As the Earth is always applying this gravitational force though, it's always changing the Moon's direction. So in practice, this means that the Moon is basically always orbiting around the Earth. Now, one of the confusing things about this situation is that even though the speed of the Moon is always the same, it's constantly changing direction. And because velocity measures both speed and direction, this means its velocity is constantly changing. So if we remember the equation for acceleration, we can see that any change in velocity, which is v, must mean an acceleration, which is a. This means every time the Moon changes direction as it orbits, it's actually accelerating, even though it's not getting any faster or slower. I know this whole concept is kind of weird, but basically just remember that because the direction of the object is changing, its velocity is changing as well, which means that it must be accelerating. So overall, there are two things to think about: the instantaneous velocity of the orbiting object, and the gravitational pull of the larger object that is orbiting. It's these two things together that result in a steady orbit. The last thing we need to look at is the relationship between the size of an object's orbit and its speed. Let's imagine for a moment that we pulled the Moon's orbit inwards, so that it's closer to the Earth. Because the distance between the Earth and the Moon is now much smaller, the size of the gravitational force will be much greater. And so if nothing else changed, the Moon would probably get sucked in towards the Earth. To avoid this, the Moon would have to start travelling much faster, so that its instantaneous velocity increased, which would allow it to maintain a stable orbit and not be pulled in towards the Earth. So the takeaway from this is that the smaller an object's orbit is, the faster that object must be travelling in order to maintain a stable orbit, because otherwise it will be sucked into the object that it's orbiting. Anyway, that's everything for this video. So if you enjoyed it, then please do give us a like and subscribe, and we'll see you again soon.